So, good evening to all. Is the audio and video clear for everyone? Thank you. Let me start our today's session. The objective of today's session is, in the previous class, we have discussed about two-phase method. I just want to take one more example at the end on two-phase method, depending on artificial variable is still there. Under two-phase method, and today's current topic is degeneracy in the simplex table, that which I go on to discuss. And I want to take one more concept, that is dual simplex method. So these things I want to give focus on today's session, so that entire concept of linear programming will complete with regard to simplex method and other things. So the remaining parts of the course syllabi with regard to this topic is transportation problem and assignment problem, so which I am going to discuss in the next classes, the coming sessions. And after the completion of these things, I am going to give the assignment based on the previous year questions. So you take your free time, solve the questions, post the solution group. As and when you have the doubt, we are going to take a class session on that. At the end, we take a doubt clarifying session on those things. That is my overall concept. Fine. Is that clear for everyone? Any queries from your side? Yes or no? Fine. So let me take the concept of degeneracy first. We say that degeneracy as, since we are performing iterations with regard to the basic variables, the slack variables, I mean, whenever one or more solution values become 0, we call it as degeneracy. That is one thing. Another one is, since we are calculating the minimum ratio, we have a choice of getting equal ratio for two or more variables. So the ratio is equal for two or more variables. In such cases, what is to be taken and which element to be taken as pivot is one confusion. So based on that, the session goes on. Fine. So whenever minimum ratio is equal, what is to be chosen? And what is the procedure we need to follow? And we have one tie situation will happen since we are calculating Cj minus Zj. So in this case also, we have a tie situation will happen so that the values are equal, accepted in the construction of table. Are you getting the concept? We are selecting the key column and we are selecting the key row here. In selecting key column, we are basing on Cj minus Zj. In such situations, a tie will happen, accepted. Later, based on the ratio, we select the pivot element. So, suppose if you are selecting key column and you have calculated Cj minus Zj, a tie is happened, then which column is to be chosen as key column? That is one kind of doubt. So there, the procedure described is, suppose the tie is happened between the decision variables. Say x1, x2, we are calling it as decision variables. In such situation, you can choose your arbitrary choice. The choice is arbitrary. Similarly, if the tie is happened between the slack variables s1, s2 on which you are performing, then also we go arbitrary. And if the tie happens between artificial variable and slack variable, we go with the artificial variable. Clear? In selecting the key column, if ratio becomes negative, that is also degenerate case. Say, for such situations, we can have the infeasibility at that point. So we won't consider the negative ratios there. We always consider the 0 or positive. The non-negative ratio we choose always. Whether the ratio is undefined or negative, we won't consider. Actually, ratio, if you talk of physical significance, ratio is 4 means you are departing the goods 4 units for all the categories. If you talk of a physical significance. So if you take ratio is negative, how can we depart the negative things? Say, at the same time, if ratio is unbounded, so you cannot depart unbounded things. So we exclude those cases. The minimum ratio means this is the minimum criteria satisfied by the all decision variables. In other words, if you allocate the resources as per the minimum ratio, it is accepted. That is why we are choosing the minimum ratio. The underlying idea behind that is that. Okay? Fine. Now let me take a problem on degeneracy. Just hold on a second. I am going to take the problem. So this is the problem given that maximum z equals to 2x1 plus x2 subject to the constraints 4x1 plus 3x2 less than or equal to 12, 4x1 plus x2 less than or equal to 8, 4x1 minus x2 less than or equal to 8. Where x1, x2 are greater than or equal to 0. So please take a note of the problem. Since you know how to write the canonical form, I am skipping that concept. Is that required for you? Writing the canonical form, introducing slack variables? If so, I will write that. So if you are interested, can I start with the construction of simplex table straight away? Fine. So after introducing the necessary variables, the table looks like this. So 2, 1, 0, 0, 0, because we have 3 less than or equal to inequalities. In each case, we have one slack variable, S1, S2, S3. So you have the coefficients like x1, x2, s1, s2, s3 with regard to the constraints 4, 3, 1, 0, 0. So 4, 1, 0, 1, 0, then 4 minus 1, 0, 0, 1, and the solution is given by 12, 8, 8, and you are performing the iterations with S1, S2 and S3 with coefficients 0, 0, 0. Now, I left the part with you to say that you calculate Zj as well as Cj minus Zj. Just give me what is the key column we need to consider here. This is the solution, and later we go for ratio. So x1 is the key column, right? So to select the pivot element, we are going with the ratio, right? So if we calculate, it will be 12 by 4, the ratio is 3. It will be 8 by 4, the ratio is 2. 8 by 4, the ratio is 2. Accepted now? So there is a tie situation happened between the ratio for S2 and S3. So our choice is we have to pick one, either S2 or S3 row, so that the necessary pivot element will be taken either here or here. Accepted? Now what happens? Even though if you don't follow the procedure, sometimes you can make the choice arbitrarily and you follow the procedure, you will get a solution. No doubt at all. But if you want the procedure to be described, this is the way to choose the selection. I am not giving about the theoretical approach. I am just describing the procedure to select the necessary pivot element as and when the two ratios are equal in the minimum case. Okay. Now what happens? This is the identity matrix situation, right? So we are shifting the things. So this identity matrix comes here and this x1, x2 comes here. So after having this table, we are constructing a new table like this. So what we are doing here is S1, S2, S3, X1, X2. So 0, 0, 0, 2, 1, and you have the corresponding things S1, S2, S3, 1, 0, 0, 0, 1, 0, 0, 0, 1, and you have 4, 3, 4, 1, 4 minus 1. The solution comes like this: 12, 8, 8, and we calculate the ratio later. Now, is that clear for everyone how the table is changed? Yes or no? Fine. You have already selected the key column earlier. Please remember the thing. X1 is key column. You have already selected in the previous level. The thing is, you are going to set the pivot element, there you have a tie. So what happens? You take the first column and you would divide this column with the key column elements. So what happens? You are doing like this: S1 by X1. Now what happens? The thing is, it will be 1 by 4, 0, 0. Now I want to mention one thing, that in the previous table, the tie happened between what variables? Can you say? S2 and S3, isn't it? So here exactly you have three slack variables: S1, S2, S3. In the previous table, you have calculated the ratio. It appeared as 3 to 2. you are going to set the minimum ratio. The tie is happened here. So this ratio and corresponding division we are not considering. We are considering the division with respect to these two things only. So I am writing the division case here as I am putting a dash here because in the first row I am not choosing. So here what you are doing, 0 by 4 it is 0, 0 by 4 it is 0, again you got a tie. So what I am taking, I am taking the first column of the slack variables which is in the identity matrix form, and this column is divided with the key column values earlier we have taken. And how I am taking the division, the first element will not take place in the division because which won't come in the pivot element case as per the previous table is concerned. So I am taking only the division between these two values because I need to choose either S2 or S3 row and corresponding pivot element. Again, I have a tie situation happened here. Now I take the second column again. So what I am doing, S2 by X1 I am doing. If tie is not happened here, if you have two different things, you are going with the minimum of the two and the necessary pivot element will be taken. If the tie situation happens here, then you take the second column again. So column by the X1 values, this will be 1 by 4 and this will be 0 by 4, 0. So here the ratio is not fixed, it is changed. Among the two, 0 is the smallest one. So I pick up S3. So this 4 is the pivot element. That was the whole idea. Fine. Are you getting the concept or not? Any queries for anybody in the division procedure, how I have taken? We can do this by shifting the table. So without getting the confusion, the procedure is described like this. Do like this, shift the table. So we should follow the book procedure. Right. Now the concept is clear for you in selecting the pivot element. Fine. Now what happened here? Remaining procedure is common. Pivot element is there. So X3 is replaced with X1. The corresponding coefficient 2 will take place here, 0, 0. Now, can I fill the gaps of the table now? Right? So the gaps will come like this. 1, 0, minus 1, 0, 4, 0, 1, minus 1, 0, 2, 0, 0, 1 by 4, 1, minus 1 by 4. This is the next table. You can cross check that, and the solution is going to change as 402. That you can verify. Now you calculate Zj as well as Cj minus Zj, and please tell me which column should be taken as the key column now. Is that X1 or X2? Because once X1 is entered in the basis, it has less chance of getting into the next iteration again. You have done with X1, right? X3 is replaced with X1, isn't it? Exactly. X2 will come here. So again, for X2, you are taking the ratio as well. 4 by 4, 1, 0 by 2, 0. 2 divided by minus 1 by 4, it is negative, which you won't consider. Accepted? Right. So since between these two, which one is to be taken as the pivot element then? 0, right? So what will be the pivot element? 2 will be the pivot element. Then what happens? 2 corresponds to x2, so s2 will be replaced. So s1, whose coefficient is 0, s2 is replaced by x2 with corresponding coefficient 1 and x1 with 2, and you will get the modified table later. So if you are clear with this thing, I will fill the gaps of the table. Any confusion or ambiguity for anyone in getting the table? Right. Then I will fill the gaps of the table. I think right, it is visible for everyone. It is going to come as -2, the values 1, -2, 1, 0, 0, 0, 1 by 2, -1 by 2, 0, 1, and then 0, 1 by 8, 1 by 8, 1, 0. And you are going to get the solution values as 402. I hope so. The same things will come. Yes, I already mentioned that. How the second table come, you are asking? Or you are asking about the row operations? Right. So did you find there is a mistake in filling the gaps of the table? Right. So let us go with this. So this is the pivot element. You are going to do this, that this whole row is divided with 4. So 0, 0, 1 by 4, 1, -1 by 4. So you are going to modify these rows with regard to this element. So what happened, since this is 1, this is 4, if you want to make this value as 0, you have to multiply this entire row with 4 and subtract these two. So if it's say R1, R2, R3, so R2 tends to R2 minus 4 R3. That is the operation you are going to take. So if you take that, this is the case, you have 0, 0, 4, sorry, 1, 4, -1, and this way will be changed as 1, 0, 0, 4, 3, and you are doing the subtraction there. So 1, 0, -1, 0, and 4. That will be the first row. Is that clear now in getting the operation? Right. Similarly, we perform the second row also, the same pattern. So can you check ZJ as well as CJ minus ZJ values for this table? And should you check any feasibility? Is the optimal attained or not? Or you are going to take any pivot element again after this step? Right. Again, we are going with a pivot element. Where it comes? This third position, say S3. Exactly. So at this position, you are taking that. So S1 is replaced by S3. 0 will be as it is. The necessary table will take place. So can I write the final answer then? Since you know the procedure, the modification of it. Or you want the final table also? However, I will write the final table. Just hold on a second. It will come like this. So after replacing S1 with S3, it is going to happen like this. S3, x2, x1. So 0, 1, 2, and the values will come as 1, minus 2, 1, 0, 0, 1 by 2, minus 1 by 2, 0, 0, 1, minus 1 by 8, 3 by 8, 0, 1, 0, and you have the solution things coming as 4, 2, 3 by 2. The solution values will come like that. You can cross check that solution part. So maximum z is equal to 5. Since you got the values for x2 and x1, x1 is equal to 3 by 2, x2 is equal to 2, x3 is equal to 0. And maximum z is equal to 5 after substituting in the objective function value, which is given there. What is the pivot element in the previous case? In the previous case, the pivot element is 1. Because this is the thing. I hope that this will be the pivot element. If there is a small miscodification here, you get the negative sign here. So this will be 4 and this will be 16. So pivot element will correspond to 4. Right. So my whole idea is to give the idea of how we are going to solve the degeneracy concept in this. So in a nutshell, what you are doing, you are simply doing, of course, actually it comes as 0 itself, but we are avoiding that. So let us do like this. Suppose if you take 0, then what happens? You are going to replace x2, right? Minus 1 by 2. Again, you are going to repeat the procedure. That's the problem. That's why I have taken S1. Okay. So in degeneracy, what you are doing? So we are not replacing, not like that. In this case, we are not replacing. In general, if such situation happens, we replace that. There is no doubt at all. Here we are not replacing it. That's all. In the case of degeneracy. Exactly. Instead of S3, if we choose S2, then we get answer in third table only. That is also true. That's why in the beginning of the table, construction and procedure, I have mentioned that this is the procedure defined to follow in solving a problem under the case of degeneracy whenever a tie situation occurs between the minimum ratio. Even though if you choose arbitrarily, you will get the solution, no doubt at all. That's why I have mentioned earlier. You can choose that arbitrarily, you will get the answer. But if you want a specific procedure, this is the specific procedure in solving degeneracy case. Right. So just hold on a second. I just want to take one more problem on this over this degeneracy. Accepted? Fine. So let us take the problem that max z 5x1 minus 2x2 plus 3x3 subject to the constraints 2x1 plus 2x2 minus x3 is greater than or equal to 2 3x1 minus 4x2 is less than or equal to 3. x2 plus 3x3 is less than or equal to 5. Please take a note of the problem. Then I will write the canonical form straight away in the table itself. Is that noted? Right. So if you take the stage of, okay, please take a note of that. If you write the zero level table, so it will be 5, minus 2, 3, 0, 0, 0, and minus m. The variables will come as x1, x2, x3, s1, s2, s3, a1. Because we have 1 greater than or equal to inequality is there, so we need to introduce an artificial variable in the first row. So how the situation comes? 2, 2, minus 1. So minus 1, 0, 0, 1. Then you have 3, minus 4, 0, 0, 1, 0. Again 0 here. And you have 0, 2, 0, 1, 3, 0, 0, 1, 0. And the basis performed variables are A1, then you have S2 and you have S3 with coefficients minus m, 0, 0. This was the table, and the solution is given by 2, 3, 5. And you are going to get the ratio as well. Please check if I go wrong anywhere. Is the table accepted to everyone? Now you calculate Zj as well as Cj minus Zj. Since greater than or equal to case is mentioned there, I have to apply the big M method. I have no other option. So artificial variable as well as surplus variable both are introduced there. And since m is involved, you will get the values in terms of m while calculating Zj. So you just tell me which column is to be taken as the key column. So if we calculate Cj minus Zj, it will be 5 plus 2m here, and here you will have minus 2 plus 2m. Accepted? So among which the most positive one is 5 plus 2m. This is the key column. Now let us go with the ratio case. So what has happened here? If we divide with the solution with the corresponding key column values, 2 by 2, the value is 1, 3 by 3 value is 1, 5 by 0 it is undefined, we don't consider the case. So you have a tie situation happened here. Now tell me what we are going to do here. Can we straight away shift the table or any other thing mentioned? I have mentioned that whenever there is a tie situation between the artificial variable and the slack variable, always give preference to the artificial variable. There is no shifting of table we should expect. Because artificial variables are introduced in the problem to solve the system. That's all. That is their only physical significance. So as and when the artificial variables are removed, then only we will get the optimal solution at the end. So our fundamental thing is eliminate the artificial variables. So these must be replaced. So if you take that, 2 will be the pivot element. So I have chosen this example to give clarity over this thing. Accepted? If a situation happened between the two slack variables, type situation, you can choose arbitrarily and we can shift the table as per the procedure which we have considered earlier. So this thing will suffice you. Shall we go with the further tables? Right? So you are going to get the things as 5 minus 2, 3, 0, 0, 0, minus m, x1, x2, x3, s1, s2, s3, a1. It is replaced by a1 is replaced by x1 with coefficient 5, s2, s3 will remain here 0, 0. The table will come like this 1, 1. So minus 1 by 2, minus 1 by 2, 0, 0, it is removed. Solution, you are going to take it as 1, 0, 5. Zero minus 7, 3 by 2, 3 by 2, 1, 0, 0, 1, 3, 0, 0, 1. This column we violate. So this was the next table. Now the remaining procedure is same. Now you can understand that since the artificial variable is removed here, it is nothing but our regular simplex method following the regular procedure. Doing the iterations, no difficulty at all at this point. If you accept with this table values, I will erase this and I will write the further iteration thing. Is that acceptable for everyone? Okay. So just give me which column is to be taken now, the key column. Along S1, S2, S3. Right? We should go with X3. Please check on that once. And pivot element will be 3 by 2. Because 0 is the minimum ratio here. If we calculate the ratio. Please check, is that key column correct or not? If so, I will write the next table. Just compute Zj as well as Cj minus Zj. I am skipping these steps because I feel that you have gone through the knowledge of these things, what is to be taken care of next. Or if you are interested in getting Zj, Cj minus Zj values, I will do that also. Is that required? Filling every time? Okay. So I will write the next thing. So S2 is replaced with X3 with corresponding coefficient 3. So you will have the case like X1, X3, S3. So 5, 3, 0. The tabular values will come like this. So 1, minus 4 by 3, 0, 0, 1 by 3, 0. Again 0, minus 14 by 3, 1, 1, 2 by 3, 0, 0, 15, 0, minus 3, minus 2, 1. As well as artificial variable is removed at all. There is no need to fill that. And you are going to get the solution values as 105 again. I hope so. The same values will come here. So further iterations will be computed by you. So if you are interested, I will write the final solution straight away. X1 is equal to 23 by 3, X2 is equal to 5, X3 equal to 0. And maximum Z is equal to 85 by 3. That was the final answer. So what happens after replacing x2 here, in the next iteration, again you are going to replace the decision variable with one of the slack variable, because optimality is not at all reached. So one more table is continued. So this is the final answer. So for the time being, I have mentioned the answer straight away. You can cross check. As per the key, I have taken these values. I think the key will be correct. So I think that this clarifies the thing over how to do the problem as and when a degenerate situation is there. A tie happens between the minimum ratio. Clear? So can I start the other one, the dual simplex method? Please tell. Okay. Can I erase this whole thing? Right. So dual simplex method, so it is, in a nutshell, if we think of this procedure, whenever you have a simplex table, what we are doing, we are taking the key column first, then on this we select the key row, we have the pivot element. So this is step 1 and this is step 2. Accepted? So far we are doing in a simplex method like this. We first select the key column, then we select the key row so that pivot element will be obtained. Now in dual simplex we do the reverse. So first we select the leaving variable, the key row. This is step 1. Then we select the key column. Then the pivot element will appear here in dual simplex method. That is the whole strategy. Performing row operations, checking optimality condition, everything is common. No change at all. Only the selection procedure is reverse. Does it make sense for dual simplex method? And we always do with the maximum Z functions only in dual simplex. So if the objective function is maximum Z, it is okay. If it is given as minimum Z, we multiply the objective values with minus and we take that minimum Z is equal to minus of maximum Z. So all the objective values are multiplied with -1. And usually what happens, as and when we have the inequalities are framed in a LP problem, they may be of the mixed type, less than or equal to and greater than or equal to. So if for a maximization problem, always we take the inequalities of the type less than or equal to. Whenever an inequality is there with greater than or equal to, we multiply both sides with minus and convert it into less than or equal to. That is the case we do in dual simplex method. So what we are doing here, we are following 3 steps. Step 1, always the objective function must be maximization. Whenever it is minimization, we multiply with minus the objective function. Step 2, all the inequalities must be of the type less than or equal to, so that there is no need of artificial variables case here. So whenever there is a greater than or equal to inequality is there, we multiply with both sides minus, convert it into less than or equal to. And what is third step? Since we do key column in the first sense, we are doing reverse. We are selecting key row first, then we are selecting the key column. That is the whole strategy. Fine. Is the methodology clear or not? Right. So let me take a problem on this. So just hold on a second, I will take a problem. So the problem which I am going to take is just fight for this. Right? Maximum z minus 2x1 minus x3 subject to the constraints x1 plus x2 minus x3 is greater than or equal to 5, x1 minus 2x2 plus 4x3 is greater than or equal to 8, where x1, x2, x3 are greater than or equal to 0. Please take a note of the problem. After noting, please inform. Fine. Now, since the inequalities of the type greater than or equal to, we have to convert them into less than or equal to by multiplying with minus. So what we are doing here, minus x1 minus x2 plus x3 is less than or equal to minus 5, and minus x1 plus 2x2 minus 4x3 is less than or equal to minus 8. And to write the canonical form, we introduce slack variables here. So these two can be written as minus x1 minus x2 plus x3 plus s1 equal to minus 5 minus x1 plus 2x2 minus 4x3 plus s2 is equal to minus 8. And objective form, you are going to take it as minus 2x1 minus x3 plus 0 into s1 plus 0 into s2. You please check on these two. How these are changed from this to this. Earlier we have discussed that always the right side values must be non-negative, but here in dual simplex we are taking the minus sign also. So it indicates that whatever may be the initial solution you are starting for the iteration, whether it is unbounded, negative, infeasible, by performing certain iterations, the infeasibility will be removed and you are obtaining the feasible solution. That is the case. Okay. Is that canonical form clear for everyone? The objective function as well as this form? Right? So can I build a simplex table then? Okay. So just hold on a second, I will write that. X1, X2, X3, S1, S2. The values are -2, 0, -1, 0, 0. We are performing with this thing. S1 and S2, 0, 0. So -1, -1, 1, 1, 0. Then you have -1, 2, -4, 0, 1. And the solution will come as -5, -8. And you are going to calculate the ratio next. So I request you to calculate Zj as well as Cj minus Zj first. Then I will describe the procedure. Okay. So here all Cj minus Zj values are negative and 0. You feel that optimality is achieved here. Please understand that if optimality is achieved, is the solution is negative? Can you say that the solution will be negative for x1, x2, x3? No, right? So we are applying the dual simplex method unless these values turn to be positive, the solution values, right? So whenever you have the solution column is negative, we are starting this procedure, the dual simplex method, because we have converted the inequalities from greater than or equal to the less than or equal to. Clear? You should remember one thing. If they are not converted, obviously we should get a key column. Now what is the procedure we are following here? We first select the key row. Now please understand, among the two negative values, we are going to select the most negative value. So among these two, this is the most negative, this is the key row. Now please give me Cj minus Zj values to me. Cj minus Zj values. Nothing but -2, 0, -1, 0, 0. Accepted? Right. Now to select the pivot element, we are dividing the Cj minus Zj with the key row. Please understand, we are doing the process in the reverse manner. We are selecting the key row first. How we are selecting? In the solution, you will get the negative values. Please understand that some values are positive, some values are negative in the solution criteria. So among the negative solutions, we are selecting the most negative solution. Let me say, if the solution value is appeared to be like this, 5, -2, 4, -3. Some values are positive, some values are negative. So among these two are negative solutions, in which -3 is the most negative. This will be selected as the key row. So among -5 and -8, this is the most negative, this is key row. So to select pivot element, after calculating Cj minus Zj, you divide this thing with the key row and the ratio will appear here. So we calculate the ratio here. So there you calculate the vertical ratio. Here you calculate the row ratio. That is column ratio, that is row ratio. There is the difference. Does it make sense? Now here, -2 by -1, 2, 0 by 2, 0, 1 by 4. This is undefined. This is 0. Accepted? Fine. Now, which one we are going to take it as the key element, the pivot element? x1. Sorry. Yeah, right. How can you say that x1 will be the pivot element? Always we should take the ratio as minimum. What is the minimum ratio among these things? One by 4. So that is we are going to take. So this will be the pivot element. Because these things we are not considering for the replacement. So you are considering only these values. Among the three we are going to select, right? Fine. So the rest of the procedure is similar. There is no change in construction of the simplex table, finding the solution and modifying the rows. So if you build the next table, how we actually do? This row will be divided completely with the pivot element, and S2 is replaced with X3. The coefficient -1 will come here. So S2 is replaced with X3. The coefficient -1 will come here. S1 and 0 will remain. This whole thing is divided with -4. So this will be 1 by 4. So -1 by 2, 1, 0, -1 by 4. And solution here you will get 2. And the corresponding modification will be done here. The same row operations will perform what we do regularly with the simplex table. Clear? So the only difference for the regular simplex method and dual simplex is we are selecting the leaving variable first. Key row we are selecting. Based on the division, we are selecting the pivot element, the key column. And doing the row operations, everything is common. There is no change at all. So here I want to stop the discussion about this dual simplex method. Because rest of the things are common, no change at all. The only modification is selecting the key row as well as key column. That's it. No change is required there. Any queries so far? So if you want a modified thing from that, I will say this was the modification which you got. So if you calculate the corresponding row, it is going to appear like this: -5 by 4, -1 by 2, 0, 1, 1 by 4. And the solution part, here you have 2, and here you will get -7. Please check. So 0 you can process that, no problem at all. We can select 0 also. So S1 is replaced by X2. That is true. Right. So you are talking about the next iteration, right? S1 must be replaced by X2. For the next stage you are talking. Fine. So because this is the key row, you select Zj as well as Cj minus Zj, divide with the elements. This will become the pivot element. So S1 is replaced by X2 with corresponding value 0 there. Performing the row operation is similar. So you are going to get the final answer as, just hold on a second, I will give the answer for you. So in solution, all positive values comes 14 and 9 at the end, you are saying, right? Right. So please give me the values also. You have the three things: x1, x2, x3. You please give me the solution values. Right? x2 is equal to 14, x3 is equal to 9, and x1 equal to 0. Right? And you have the maximum z case. Did you calculate that? Maximum z value? Minus 37, right? So, as far as the examination point of view is concerned, I give less priority for GL simplex method, because as and when a problem is posed, always we go with the regular simplex, big M method, sometimes occasionally two-phase method, and writing the dual, we solve the problem. So, dual simplex has less priority with regard to examination point of view. It will be asked less frequently, not always. Okay. So, can we say one thing, that dual simplex method is somewhat similar to the dual method, writing the dual of a problem and solving? Can you say like that? Is that somewhat similar to dual of a problem and solving by using simplex method? I have exactly taken the value given by our friend. I didn't substitute that actually. If it is -9, I will take -9. I simply taken the value by your inputs only, as per his consideration. So -9 is the final answer. Right. So the question is here that is GL simplex somewhat similar to dual of problem? Because in dual of a problem, what we are doing actually, if you take a small example, that say minimum z is equal to 2x1 plus 3x2, subject to the constraints x1 plus x2 is greater than or equal to 4, x2 minus x1 is less than or equal to 6. Take like this. So if you want the construction of the GL problem for it, it will come like that: maximum z as 4a plus 6b, subject to the constraints a plus b is less than or equal to 2. But one thing we need to remember, that always the values must be less than or equal to type. So we are going to convert this. So it will come as minus x1 minus x2 is less than or equal to -4. This will be -4a. So minus a plus b less than or equal to 2. And from this, minus a minus b is less than or equal to 3. So this is the dual of the problem. So there you do key column is nothing but in GL simplex key row. You can cross check the things. Because here what you are happening, you are simply taking the inequality exactly and you are doing the problem. So in one way, I feel that GL simplex is somewhat similar to GL of a problem. The procedure is different, I feel like so. Right. So at this point, we have covered all the models with regard to simplex table and methods. If you have any queries, you please ask. Any queries so far in the procedures described? Say yes or no. To anyone? Okay. So I want to start a new topic, that is a transportation problem. So I want to postpone it for the next session. So two-phase big M is easier or simple big M? Yes. So if the problem is asked for big M method, we should follow big M straight away. The thing is, whenever greater than or equal to inequalities are there, I say that you can apply two-phase method, which simplifies the computational process. Because two-phase method is very convenient, because for the artificial variables you are taking 1 and -1, right, in the coefficients. It simplifies the procedure in calculation of the tables. So you can apply two-phase method. So two-phase big M method is easier than the simple big M method, because the involvement of M is avoided there. So you can follow the two-phase method. Other questions, please. Right? So I think you have a little confusion with regard to the basic solutions, feasible solutions, etc. I hope so. Right? So just say for basic solutions, we simply say that a solution which satisfy non-negative restrictions, and it is a solution. And second one, feasible means it must satisfy in the feasible region. So it is a basic solution, that means satisfying the condition having non-negative restrictions, and it must come under the feasible region. So optimal means giving required value for Z, the best value of Z. And if you want to degenerate, since you are starting the basic variables, say S1 and S2, or if you have S1 and S2, since you have taken a basis, if in the basis one or more solutions are zero, that is called degenerate. Right. So a solution which is not degenerate, we call it as a non-degenerate solution, in a simple manner. That is the thing. Okay. Is that clear? Satisfying non-negative restrictions is basic. Coming under the feasible region, we are calling it as the basic feasible solution. Optimal, giving the best value of Z. And degenerate, let me say, if you have the basis x3, x4, you have found the value of x3, you have found the value of x4. x3 is a positive number, x4 is a 0. Since the solution has become 0, it is a degenerate solution. That's it. If the solution values are all positive, you can say it is non-degenerate. If one of the solution values is 0, we can call it as a degenerate solution. That's it. So for book reference, sure. For book reference, I will give a picture for the definition of these things. You can check that. If you are following, it is okay. Right. So as per the question you have asked, so you have mentioned that x1 plus x2 is equal to 120, x1 less than or equal to 60 and x2 greater than or equal to 40. The question is how to solve with two-phase method, right? So first of all, let us write the canonical form. Since this is equal to, we should introduce the artificial variable here. So x1 plus x2 plus a1 is equal to 120. And here you have the surplus slack variable. So x1 plus s1 is equal to 60. You have the artificial variable as well as the surplus variable. So x2 minus s2 plus a2 is equal to 40. This is the canonical form we write. And you have given that minimum z is equal to 4x1 plus 6x2. Okay. I think I have mentioned that in two-phase method, if the objective function is negative, you can take it as minus of z, right? Or you can keep it as it is. But some others mentioned that you take minus and convert it to maximum z. I hope so. Or you can leave as it is, no problem. So if you fill the table, it is going to come as x1, x2, s1, s2, a1, a2. So we take all the coefficients as 0. So if you take the objective function as it is, as minimum z, this will be 1, 1. The artificial variables. And from the first equation, you can say that 1, 1, this is 0, this is 0, 1, 0. From the second equation, it is 1, 0, 1, 0, 0, 0. And from the third equation, you have 0, 1, 0, minus 1, 0, 1. This will be the form. So now, in which, what are the basic variables here? We call that a variable is basic, whose coefficient is 1 in the one row, in the all the other it has coefficient is 0, right? So you take a1, here s1, then a2. So a1 coefficient is 1, s1 coefficient is 0, a2 coefficient is 1. This is the thing. And if you come up with the solution, so here you will take 120. In the second inequality, I think it is 60 and it is 40. I hope so. This is the solution. And you start doing the performance. I think by putting equal to what to do, you have a doubt. I hope so. Right. That's the thing. Yes. How first line came? So you have x1 plus x2 is equal to 120, right? Say the first equality is given. So here what you are doing, since it is not less than, not greater than, you cannot introduce a slack or surplus variable. But you want an identity matrix type, so that we are introducing the artificial variable here. Plus a1 is equal to 120 we are doing here. That's it. So if you put x1, x2 as 0, a1 is equal to 120 is the basic solution. The first time how you have written, right? So this is the first equation. The topmost you are asking, right? So in two-phase method, we take all the values in the objective function as 0 first. Then after achieving the optimality, then you go with the second phase with filling the gaps. 4 and 6 will come here. The two-phase method. Fine now? Right. Any other queries, please? Have you started solving the previous year questions regarding graphical method and simplex? Or you didn't try, right? So would you mind if you just post the solution in the group, other people can access that. And the doubts will be discussed in the class at the end. So in the next class, I am going to start the transportation problem, which will be very interesting compared to the simplex method. And you like those problems most. I hope so. Transportation problem and assignment problem, which you like most. So that's all for today. Let us wind up our session here. And tomorrow we will meet. Thanks to all. Any other queries you can ask. Say yes or no. Thank you.